Good morning. Thank you for coming out this morning. I thought that I'm Cherilynn Morrow. I'm a senior research fellow for science education at the Aspen Global Change Institute over the hills here. Although I'm currently based in Atlanta. Let's see, I'm going to use this. I thought the session yesterday afternoon was extremely inspiring, and if I'd known about it, I might have contributed another talk related to an art science project called AstroJazz, where rather than being the physics chanteuse, I'm the astronomy chanteuse. But after yesterday's session, I thought maybe I should become a geojazz chanteuse. And I've already begun, inspirationally, to morph some of the parodies that I've done in the original tunes into things that work on the life science or in the climate change realm. So I'm looking forward to further inspiration from those around. So my alter ego as a jazz vocalist was excited yesterday. I also have a proclivity for interdisciplinary exchange, and this was born, my graduate years were spent at NCAR around people like Walter Orr Roberts, Jack Eddy, Steve Schneider, Ralph Cicerone, all very interdisciplinary thinkers. And this has been highly influential to me in regard to the work I'll describe and the work I'm currently doing. I'm going to use the context of a concept inventory, and I hope to describe to you what that is and what it's good for and how we developed it, although I'm not going to focus there because it's a more detailed presentation about that is available. I want to say something about what we've learned in the process of developing this. I want to emphasize that, and something about how we attempted to address student reactions of bias. They would happen in interviews, and they would also happen informally after taking the versions of the tests that students would come up and make remarks. And I wish I had the risk communication specialist advice in the early going of that, but I finally had to construct how to deal with that as a researcher. And also I'm going to invite anyone who's interested, and I already know a few of you I'd like to target for this purpose. We're doing our final round of expert review. We've been in development for 3 years on this concept inventory. And it's about a 20 to 60 minute time investment. It's an online survey. And if you have an interest in that, please do come and see me because I might not target all the people that might find that of interest. So since the summer of 2011, we've been gaining insights into how a large and diverse population of undergraduates at the Southeastern Research University, I guess it's no secret that because of the seals on the opening slide where that is, but we've also, a concept inventory is a carefully designed multiple choice test. And the idea is it's more than a factoid, you know. It's, in other words, the questions, the items, are not just, do you know this fact? Some of them are knowledge-based facts. Others are more asking you to apply conceptual knowledge. So it's an attempt to use a multiple-choice test to get at deeper understanding. That's not a trivial task, and it's not entirely possible. Right, without open-ended questions, you really can't get at a deeper conceptual understanding, but it does have some valuable uses. So we've been conducting this research in the context of a 4-credit-hour introductory undergraduate course on weather and climate. And these are non-science majors. Okay, that's the wiki definition. Right now we have 36 items. I'll keep going. Here's a kind of an example of a more fact-based item related to what is a climate model. And there's just a structure. There's some of the jargon that we use. This is a stem, this is a substem. These are distractors or answer choices. And you try to create distractors in a way that use the common misunderstandings that are out there. So, for example, we also try to classify by cognitive level. What are you asking the student to be able to do? So have a look at this item, if you would, and see which of the categories you believe. So in just a few seconds, I'll ask you, which of these categories do you believe this item belongs in? Is it knowledge, asking for a knowledge of a fact or a definition? Does it require a little more comprehension? Is it an application of a conceptual understanding? And I'm going to just poll you here in a second. What do you think? So how many would call this a knowledge factor definition type item? How many would say, oh, well, that's a little more sophisticated than that, knowledge comprehension? Cool. And then what about application analysis, X for application? Okay, that's really good. That's great data impression for me. This is actually a part of the review to ask you to look at items with this in mind. So thank you for that. These are some recent item frequencies, we call them. This number, of course, I guess I have one of these, and I'm going out of the range of our global audience. I'm sure there's a global look, yes. These are percentages. 17% selected A, 3% selected B, 33% C, and 47% D. Is that clear? Yes? So these are item frequencies on our recent versions, one of our most recent versions this spring 23 semester. And the N values are over here. So basically, this is a kind of data that we take. And notice there was a shift pre-post to the correct answer. And also notice in the early going, this distraction to the notion of high humidity being climate, right? So that some climate variables, or some weather and climate variables, precipitation, humidity, rain, all of that, students have this idea that, oh, global average temperature is about climate, and high and low temperatures that the weatherman says are about weather. And they have different kinds of conceptions. It's fascinating to talk to them about that. So humidity, people think of as being climate and climate control. At least a third of the students at the beginning of the semester. Interesting. The content validity for our concept inventory comes from this document. How many are familiar with this document, the Climate Literacy Principles? A well-vetted document. I have a hard copy here if anyone's interested in having a closer look. And a lot of agencies and partners, we figured, okay, this is a good content validity base. We'll go with that for the basis for choosing content to address with our items on the concept inventory. So there's a kind of graph just telling you something. We have an emphasis on system interactions and variability in space and time. And we had other sources of stimulation for our item development, the IPCC FAQ, which is hard to find. Susan Hassel wrote that as an addendum to the working group too. Also, this paper was mentioned by Somerville and Hassel, the Physics Today article on climate communication for terminology, right? Making sure that this really worked as a pre-test, not just only as a post-test after you've been exposed to a lot of jargon in the course. So we really tried to weed that out. Also, we did look at the questionnaires whose analysis resulted in the 6 Americas report for stimulation. We're not asking about global warming opinions. We're really at the content such as you would encounter in a course. Also, the research based on misconceptions, and Mark McCaffrey is the same guy who's in the room here, who was on a paper with Susan Burr related to misunderstandings. And these are sources of information in regard to the distractors we're choosing. So in the end, we're trying to develop a concept inventory that's a valid approach, research-based, to a first-order assessment of literacy about climate change, as opposed to literacy about the broader domains of weather and climate. So we're not trying to be the final exam in this course, but we also do include a subset of basic weather and climate concepts that support the understanding of climate change and its consequences. So here's the mantra, the sacred saying of good item development. The student who understands gets it right, and the student who doesn't understand gets it wrong. Okay? So that's easy to say and very, very challenging to do. So you want to be in these boxes here. Somebody who knows gets it right, somebody who doesn't know gets it wrong. If the interviews and the quantitative data reveal that you're in one of these boxes, a student who knows is being fooled, or a student who doesn't know is easily able to guess it right, then you're not happy with that item and you want to try some new things in order to make it a more valid assessment of whether or not they know the objective of the item that you're after. So here's something that you'll see on the survey. These are our kind of, I'm sorry, that's not very easily read, but we want to make sure we're covering appropriate skills. We want to have suitable language. We want to have an appropriate level of difficulty for these students, and that's been very challenging to get it at the right level. We went in way too high. right? We had far higher expectations of what they would be able to do, and we've had to simplify considerably in order to get item difficulties in a reasonable range, okay? Ability to discern one unambiguous right answer for all items, also more difficult than it seems. Use of appropriate distractors and the practicality of use. Is it an acceptable length? Is it okay? So in order to do this, we have quite a development team. I'm primarily covering the Think Aloud protocols, the interviews that we do right after they take different versions of the concept inventory. Psychometrics is this, there's a whole field devoted to developing assessments. And this gal is the executive director of assessment and evaluation for all of the University System of Georgia, and NSF calls on her constantly to review proposals and to assess assessments. So we're very fortunate indeed to have her on our side. And also the executive director of the Aspen Global Change Institute, who's sat through 20 years of small assemblies of climate and global change folks. Very deep science knowledge, and also was a high school educator. So he is been a beautiful colleague for combining the science and education. So we're really gluing together to combine our expertise. Often you can have a really good statistical test or really good content, but they don't go together. And we really have a powerful team for making that combination work. Richard Somerville has also been an extraordinary asset. He came to Atlanta at the AMS meeting and visited us, and he gave a public talk on campus. As many of you know, he's also developed a popular book that got an AMS Book Award based on his work in teacher professional development. That's where the content for that book came from. And he gave a very authoritative, straight science talk, and we learned a lot from that that caused us to influence our concept inventory. Richard came to, for 10 years, I was NASA and NSF funded to do workshops for scientists about their partnerships in education. And Richard was one of those students back then. For a long time, he's been interested in how to become a better educator and a communicator. And now, of course, this is like an example of the curriculum in such a course, right? So go ahead. It is a very important class that you learn about Celine. Celine is a new form of Zionter. It's monotilde and seristana. You get the idea? Do you know if am I serious? No? Okay, well, what is Celine? It's a new form of, yes, where is it monotilde? Oh, great. So now the point is you can answer these questions, but the jargon, it's so what? What do you actually know conceptually? And so, of course, we're trying not to do this. Okay, so here are some observed attributes of his talk. We took data after this talk and we said, have your attitudes about anything shifted? And a significant number of students who'd been exposed to the Rush Limbaughs and the so on that you can readily have access to in the Southeast said that they need to think about this again. Right? So there was some indication that a straight science talk, he made a firm opening disclaimer, I'm talking to you about science, what 90% of the actively practicing research community thinks is going on, and I won't be saying anything about politics or ideology. He said it specifically. He implicitly debunks myths and misunderstandings, but makes no explicit reference to them. He invoked the history of science, which we've heard about. He took care to describe terminology that he thought might be unfamiliar, and he made evidence for knowledge claims. He explained clear and articulately with the use of metaphors. He didn't use emotion and dancing around, which is also effective in certain audiences, but his natural style played into the role of what they might have expected from a traditional scientific authority figure, so it's fine to be dry, relatively speaking. He conveys information from an authoritative base, but he doesn't tell them what to believe. So this arose the distinction between being authoritative and being authoritarian. And those are just, I know it's scary because I'm going to go over just a couple of minutes here. Authoritative versus authoritarian, favoring complete obedience. He didn't tell them what to think, and I think that mattered to undergraduates, the adolescents who are in the process of being invited to critically think, and they're also examining and challenging the parental values and the things they've heard in their families. I think undergraduates are a very ripe place for our climate communication efforts. I think it's an extremely important time. And this inquiry versus dogma framing that I constructed on my own, but we heard it presented yesterday, I think is very important from our philosopher. I'm going to skip over this, but I want to talk more about that with the educators in the audience. So we endeavored wherever possible to make these items refer to evidence rather than making them more factoid. This is a factoid. Do you know how the temperature is increased? But we're also referring and appealing to the data or the measurements. So wherever possible, the items in this concept inventory are doing that, rather than just asserting, well, there's just some dogmatic claim out there. So that's a little bit of a picture of the demographic that we had. They're young, they're non-science, and they're very diverse in their ethnicity. They're also female majority. Quantitative and qualitative methods. There's a whole paper. I want to say that we really vetted the graphics. Some work, some don't. There's a whole, I have a whole presentation about the developmental process. I'll say more. So I quickly want to say, I'm aware that K-12 realm and standardized testing feels like this about the use of such tests. Anybody relate to that? No? Okay, so we're trying not to do that. But what I want us to focus on now is that the multiple choice test cannot purport to assess deep conceptual understanding, but if well developed, it can flag conceptual issues, detect conceptual change, and inform decisions about teaching strategies. And in higher education, there's precedent in physics, for example, for the forced concept inventory to really help to revolutionize the quality of teaching in the undergraduate class as teachers become more aware and shocked by what their students do and don't know, pre and post. Okay, thank you very much.